students, my name is Akash Shetty. Today I am going to teach the most important topic is hydraulic jump and how we can derive the hydraulic, that also we'll discuss. Before going to that, what do you mean by hydraulic jump? That we need to discuss. Just draw them. Hydraulic jumps. When the water is flowing, so this is surface. For example, this is on the surface of the earth or canal. So when water is flowing, this is gradually where it flow. And suppose here one dam is there. When water crosses here, sudden that velocity will changes, and again the water will rise. So this part, so this one is, we can say this is H1, and this one we can say this is H2, and this one we can say this is H3, and this one we can say height 4. So this is 1 meter or 2 meter, and this is for 5 meter. So the for different distance, the height will changes. But this variation is called gradually varied flow. Gradually varied flow. And when it is that is, we can say dH by dx, it's not is equal to 0, because this is exist, that one height and x with respect to height, it's in any distance, it means 5 or 3.5 or 4, for any distance it exists. So this is gradually varied flow, means it's slowly the height of increases till when its obstruction comes. When it passes, what will happen? So this is, suppose I am considering this section 1 and this is section 2. See here, sudden changes of height will occur. Sudden changing of height. What will happen? Sudden changing of height. Why it is? Because when why it is happens, sudden changes means here what happens? Here the some things happens. Something is going on. What I am going to explain here. So here is same zoomed portion of here. If this is specific energy and this is H, what happens means when it is, this is flow, water flows like this, or I can draw like this graph, or I can draw this diagram. Here the SC is minimum, specific energy is minimum specific energy, and here this is critical velocity, we can calling HC, critical height or critical velocity. Here Froude number is equal to 1, and here the Froude number is more than 1, and here the Froude number is less than 1. So what will happens here? The same thing here, when it touches here, the water will the unstable condition, because it's not stable. So whatever it is happens, when if it's unstable condition, it's trying to stable. This water portion is trying to stable. When it's disturbing, it will going to reach stable conditions. In that process is called hydraulic jumps. In between, that's very short period, again it's going in stable position. When here the total water is disturbing, again it's going to original position and stable position. That is called hydraulic jumps. Whenever it's disturbing, here the water is totally disturbing, again immediately it will go for stable position within a short time. That is called hydraulic jumps. So where it is happens means when it is the water level, the height of the water level, this is why I can say D1, the height of water level, this is D1, height of water level is below the critical height. This is, we can get critical height or critical depth. The water level is D1 is below the critical depth, then it is, we can say, unstable flow, and if it is more than, we can say that is a stable flow. So here we can say that this is below the critical depth, and the D1 is totally unstable condition, and it's trying to get it the stable condition. And here we can say that when it's stable, Froude number is less than 1, it is, we can, here the water is in stable condition, here the Froude number is less than, because its depth is below the critical depth, and his Froude number, when it is critical number depth, here Froude number is, we can consider its Froude number is 1, and here the specific energy also minimum, because the water is below the critical depth, height is below the critical depth, here the specific energy also minimum. So that is a small description of hydraulic jump, how it is occurs hydraulic jumps. So this D1 and D2, this is we can consider as D2, and D2 minus D1 is difference depth. Difference depth, D2 minus D1 is difference in depth. So that I am going to and this is a small explanation about hydraulic jump. Hydraulic jumps, we can, I can say this is a hydraulic jump, small explanation about hydraulic jumps. I hope all of you understand. When it is water is flowing from gradually from upstream side to downstream side, when the velocity variation takes place, sudden velocity variation takes place, that is called hydraulic jumps. So what is the main portion I explained here, that this is a small zoomed portion of this here, that when you are drawing the graph of the specific energy curve, that is we are having critical depth, when it's below the water level is below the critical depth, that we can consider it as undisturbed disturbed flow, and or unstable flow, and this is trying to get in stable flow within a short period. That processing is called hydraulic jump, that I can say. And that's most important part is derivation of hydraulic jumps. We'll go for that one. Derivation part of hydraulic jump, how we can derive the hydraulic jumps. So what I said, the previous explanation, the water will flow, this one we can start from here, derivation of hydraulic jump. Derivation of hydraulic jump. First, I can say the water is flowing this. We are considering two section. I said the two section is, this is surface of the bottom surface of flow. If you consider two section, this is 2 2, and this one is 1 1. Two section is there 1 1 and section 2 2. Here we are drawing that pressure distribution diagram. Anyhow, we are having the pressures. This is a non-uniform flow, and that is when we are considering the here the two side is velocity same, so there is no accelerations. And section 1 and section B, section 2 2, and here dV by ds is equal to 0. And here we need to make a pressure distribution diagram, and slope also here some consideration we can, slope also negligible here. Once in slope is negligible, because very small portion of slope, so we can consider slope is negligible here. Once assumptions, what I am saying, assumptions, slope is negligible, and we are considering the hydrostatic forces, hydrostatic force and pressure distribution both side, distribution of both side, and here velocity with respect to both the side, dv by is equal to 0 minimum. When the velocity is same in both the, velocity is same in both the section, and this is next what, this is a small assumption we are considering. And here I am drawing the pressure distribution diagram here, one pressure section 2 2, when we are deriving the hydraulic jumps here, you can say here the two section is there, one section and section 2 section 2 is there, and in that I am considering the assumptions here slope is negligible, because very small slopes we are considering, that is, so that reason slope is negligible. And the second is the hydrostatic force we are considering here, and pressure distribution, the way drawing the diagram of pressure distribution both side, and velocity is minimum, velocity same in both the sections 1 and 2. And here that is derivation of hydraulic jumps, I am going for that dz1 is equal to here the two section pressure distribution is there, one is section 1 and section 2. Here what will happens here, this d1 is there and this d2 is there, and that we are considering here, that is one rectangular channel, and the two side is rectangular channels we are considering. We are considering to calculate calculation that derivation of hydraulic jumps. Here the two section is there, section 1 and section 2. Above the section 1 I drawn one small rectangular channels, because here we are assuming that channel is rectangular, and here also we are assuming that channel is rectangular. So depth is d is equal to center of pressure is equal to d1 by 2, and in the section 1 and section 2 is d2 by 2, z2 is equal to d2 by 2, and the two pressure is acting, one is p1 in this direction, and at the same time that opposite direction also acting, that p2 pressures. Slow that some assumptions now consider model, slope is negligible, and hydrostatic forces the consider model the pressure distribution diagram of both side, and velocity is minimum in both, same in both the direction, there is no accelerations ಅಂತ consider model both section ಅಲ್ಲಿ velocity there is no acceleration. Hydraulic jump ಅಂದ್ರೆ when some comment I got from YouTube personal messages, it means like you need to explain in Kannada also, so that reason I am explaining in Kannada. ಸೊ ಕನ್ನಡ ಹೈಡ್ರೋಲಿಕ್ ಜಂಪ್ ಅಂದರೆ ನಾವು ವಾಟರ್ ಫ್ಲೋ ಆಗ್ತದೆ, ಸಡನ್ ಅಬ್ಸ್ಟ್ರಕ್ಷನ್ ಏನಾದರೂ ಸಿಕ್ಕಿದ ಮೇಲೆ ವಾಟರ್ ಸಡನ್ ಚೇಂಜಸ್ ಆಗ್ತದೆ, ಅದಕ್ಕೆ ಹೈಡ್ರೋಲಿಕ್ ಜಂಪ್ ಹೇಳ್ತಾರೆ. ಅಲ್ಲಿ ಹೈಡ್ರೋಲಿಕ್ ಜಂಪ್ ಎಲ್ಲಿ ಕ್ರಿಯೇಟ್ ಆಗಿದೆ ಅಂತೆ, ಸೊ ದಿಸ್ ಇಸ್ ದ ಫ್ಲೋ ಆ್ಯಂಡ್ ದಿಸ್ ಸಡನ್ ಅಬ್ಸ್ಟ್ರಕ್ಷನ್, ಸಿ ದಿಸ್ ಇಸ್ ವಿ ಕ್ಯಾನ್ ಸಿ, ಇಲ್ಲೊಂದು ಡ್ಯಾಮ್ ಇದ್ದರೆ, ಡ್ಯಾಮ್ ಏನಾದರೂ ಇದ್ದರೆ ಇಲ್ಲಿ ಸಡನ್ ಚೇಂಜಸ್ ಆಗ್ತದೆ. ಇದು ಈ ವೇರಿಯೇಷನ್ ಆಗೋದಕ್ಕೆ ಹೈಡ್ರೋಲಿಕ್ ಈ d1 ಆ್ಯಂಡ್ d2 ಎರಡು ಡೆಪ್ತ್ ಸಿಗ್ತದೆ ನಮಗೆ. ಇಲ್ಲಿ ಯಾಕೆ ಡೆಪ್ತ್ ಅಂದರೆ ಇದು ಇಲ್ಲಿ ಕ್ರಿಟಿಕಲ್ ಹೈಟ್ ಅಂತ ಇದ್ದರೆ, ಇದಕ್ಕಿಂತ ಕಡಿಮೆ ವಾಟರ್ ಡೆಪ್ತ್ ಇದ್ದರೆ ಅಲ್ಲಿ ನಮಗೆ ವಾಟರ್ ಡಿಸ್ಟರ್ಬ್ ಆಗ್ತದೆ, ಅನ್ಸ್ಟೇಬಲ್ ಆಗಿರ್ತದೆ ವಾಟರ್, ಅದು ಸ್ಟೇಬಲ್ ಕಂಡೀಷನ್ಗೆ ಹೋಗ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತದೆ, ಅದನ್ನು ನಾವು ಹೈಡ್ರೋಲಿಕ್ ಜಂಪ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಎಲ್ಲಿ ವಾಟರ್ ಹೈಟ್ ಕ್ರಿಟಿಕಲ್ ಹೈಟಿಗಿಂತ ಕಡಿಮೆ ಇದ್ದರೆ, ಸ್ಪೆಸಿಫಿಕ್ ಎನರ್ಜಿ ಮಿನಿಮಮ್ ಇರ್ತದೆ, ಅಲ್ಲಿ ಹೈಡ್ರೋಲಿಕ್ ಜಂಪ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ. ನಾನು ಅದನ್ನು ನೀವು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಕ್ರಿಟಿಕಲ್ ಹೈಟ್ ಅಂತ ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಟರ್ಮ್ಸ್ ಇದೆ, ಅದನ್ನು ನೀವು ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು. ಯು ಶುಡ್ ರಿಮೆಂಬರ್ ದಟ್ ಕ್ರಿಟಿಕಲ್ ಹೈಟ್ ದ ಟರ್ಮ್ಸ್ ದಟ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಇನ್ ವೆನ್ ಯು ಆರ್ ರೈಟಿಂಗ್ ದ ಎಕ್ಸಾಮ್ಸ್, ಯು ಶುಡ್ ಆ್ಯಡ್ ದಟ್ ಸೆಂಟೆನ್ಸ್ ಕ್ರಿಟಿಕಲ್ ಹೈಟ್, then you will get the marks for that one. You just, if you without technical words, if you are writing that theory means it's not valid. So that reason I'm telling you should use some technical words. Critical height, if it's below the water depth is below the critical height, then it is there is a chance of course hydraulic jump. Not it, of course it's it will create the hydraulic jumps, because that it will unstable water and it will try to stable, so that we can say. And we are having the formula is F is equal to rho g a z bar. It is the vertical distribution, vertical surface submerged in liquid. That chapter we are getting this formula. F is equal to rho density, g is equal to 9.1 a and z bar. Z bar is equal to d by 2. What I said, no, that one it will act in center of pressure, because all the water is acting in the center of all the pressures is acting in center of that body, that is called center of pressure. That act is d1 by 2, that we can find. And center of gravity also important for this one, because what happens, no, when it is gravity is not proper, it is come out from that material, then what will happen, the body will inclines, there is a slip occurs. So that reasons gravity also important here. So the density g and z bar, that is that 4 parameters we are using in that derivation. F is equal to rho g a z bar. Rho is equal to density and g is equal to 9.1 a and z bar. Z for one section, z1 bar and z2 bar. That two forces, what are the forces acting on, that we can consider. Here I am not considering this one pressure, this is I am considering P is equal to pressure force, and this is P2, and this one is P1 and another one is P2. P2 is equal to rho g a z2 bar, and this one is z1 bar. So that we can consider. And d2 here what happens, P2 is more, because d2 is height is more, no, that reasons P2 is more. So net force acting on the fluid mass between two sections, net force here I'm using the very small letters here because there is no space, so I will erase this all. I will erase this. P1 is called rho G A Z1 bar, and P2 is equal to rho G A Z2 bar. So the net force acting on fluid mass between section, net force acting between section 1 and 2 net force acting between section 1 2, what, how we can write? P2 is bigger here, P2 minus P1, so it means rho G A Z1 bar minus Z2 rho G A Z2 bar. So this one area is equal to, area we can write rho G B into D. We know that we are considering the rectangular here, and Z1 Z2 here into D2 by 2 minus rho G B into D, means B1 and D1, this one B2 D2, and this one B1 D1 into D1 divided by D1 by 2, correct? So what will happen here? P2 minus net force means P2 minus P1, P2 minus P1, P2 minus P1 here. So it means what happens? Rho G divided by D1, this one D2 D2 square it happens, and this one rho G into D2 square minus D1 square divided by 2, right? Now rho G B2 square and D1 square divided by 2. Z1 is equal to D1 divided by 2, D1 square and D2 Z, this one is D1 into, sorry, this is D2 square divided by 2, and rho G into B1 into D1 square divided by 2, and here the answer is rho G. Here B is equal to 1, we should take B, breadth is equal to 1, so then it is becomes this equation we will get P2 minus P1 is equal to this equation we will get. The first equation we will get this one, P2 minus P1 is equal to D2 minus then this one. Then here we need to consider the momentum equations. So momentum means we should consider the momentum is equal to mass into velocity, and here we need to consider rate of change of momentum, law of momentum principle, rate of change of momentum is equal to mass, because here rate of change of, so with respect to time, mass into velocity divided by time. Here they are considered the rate, so that reasons we need to write this one. So we can write this one kg, mass is kg, time second, and velocity we can write meter per second, that is with respect to the unit. So first whenever we are drawing that equation is there, you just draw the unit and then we can come to know what we can draw. So first we need to bring here kg. So how we can bring it here kg? So I can bring density here, density density and density is equal to that I will explain you how it comes. Rho is equal to small q into b, v is equal to q by a, and q is equal to q by b into d, and that q is equal to small q is equal to meter cube meter per second, that we know. This discharge per unit breadth, and that is 1 meter for 1 meter distance, that is 2 meter, that is if we consider b is equal to 2 meter, or b width, we don't know that b width per unit width, this is b width for unit width, that small q, and for b meter what is the distance, that's q into b for b meter. So that is I can say that for q into b here, small q into b, and this one v1 minus velocity variation, that is velocity changes, v1 minus v2 here, this one is v1 and this one is v2, v1 minus v2. So here I can write it kg per meter cube density, we know that one kg per meter, and q is equal to, I said meter cube discharge per unit width, meter into second, discharge per unit time, and we can say meter second into b unit is meter, and this one is meter per second. So final is meter cube will cancel, meter will cancel, so final answer this one will get kg per second into meter per second. The final will get this one, the 2. So next procedure is what we can do. The moment we get rho g, the rho q b is equal to 1 here, v1 minus v2. So that compare that one, rho g d1 d2 minus square d1 square, rho g equate this one, rho g d2 square minus d1 square divided by 2 is equal to this one, rho q b, rho q b is equal to 1 v1 minus v2. Just compare that one, you can write it here. So you can write it here, rho, this one, rho q b v1 minus v2, rho q b v1 minus 1 minus v2 is equal to d v1 minus v2, that's how you can write it here, rho g d2 square minus d1 square divided by 2 is equal to rho q v1 minus v2, v1 minus v2, v1 minus v2. That v1 minus v2. So next how we can write it, next equation. So d2 square minus d1 square is equal to 2 rho small q 2q small q v rho g v1 minus v2, this one rho g d2 d1 square, this one sorry, rho g, rho will cancel, and the answer is d2 square minus d1 square is equal to 2 small q v1 minus v2 divided by g. So next d2 minus d2 square minus d1 square is equal to rho small q divided by z is equal to v1 we know that one last class we discussed. v1 is equal to q, we know that one, q is equal to a into v, so v is equal to q by a, so what we can write, q divided by b into d, so q is equal to q into qb, q divided by d, it becomes v is equal to q by divided by d, unit width. So this one I can write v1 is equal to q divided by d1 minus this one q1, q2 divided by d2. Next d2 minus d1, d2 square minus d1 square is equal to 2q, q1 2, this one if I get it outside that q1, 2q square divided by g 1 by d1 divided by 1 by d2. Next d2 square minus d1 square 2q square divided by g means d2 minus d1 d2 cross multiplication d1 d2. So what happens here, we can write it, this one we know a square minus b square, that format I can write it, this is d2 square minus d1 square, a square minus b square, a square minus b square, so a plus b minus a minus b, so I can write this one d2 minus d1 plus d2 plus d1, d2 minus d1 is equal to d2 plus d1, so I can write it 2q square divided by g d2 minus d1 d1 d2 this one, it's got it. So next I can write it here, that becomes d2 plus d1, I can rub this one, I can rub this part, d2 plus d1 d2 plus d1 d2 plus d1 is equal to 2q square divided by g d1 d2 and multiply by d2 and multiplied by d2, so next d2 square plus d1 d2. So it means 2q square d2 divided by g d1 d2. So d2 cancelling each other. Next what happens? Next question is d2 square. Next we can write d2 square plus d1 d2 is equal to 2q square gd1. 2q square gd1. Then quadratic equation, we can write it quadratic equations. I can write it here. Quadratic equations next. d2, that equation I can write it here. A square ax square plus bx plus c is equal to 0. That form you can write. d2 square plus d1 d2. Here this one bringing in this side, 2q square into gd1 is equal to 0. Here a is equal to 1, and write here a is equal to 1 and b is equal to d1. c1 is equal to minus 2q square by g d1. And find d2. Most important thing is find d2. Find d2. d2 is equal to, find d2. d2 is equal to, we are having the formula. d2 is the formula, quadratic equation. d2 is equal to minus b plus or minus root of b square minus 4ac divided by 2a. So d2 is equal to minus d1 plus or minus root of d square minus 4 into 8 into 1 divided by 2 into 1. So d2 is equal to minus d1 plus or minus root of d1 square plus 8 small q square gd1. This means v is equal to q by d. So q is equal to v into d. So d2 is equal to minus d1 plus or minus root of d1 square plus 8 q is equal to v1 d1, 8 v1 d1 divided by 2. 8 d1 divided by 2. This one, instead of, we can write it here. If I think you are getting confusions, this one I can write it here. d2 is equal to minus d1 plus or minus root of d1 square plus 8 into v1 d1 divided by GD1 v1 d1 square. This one v1 d1 square. So this all inside terms in d1 term. So I can write it minus d1 plus or minus root of d1 square plus 8 into v1 d1 square divided by 2. So divided by 2. Next you can write it here minus d1 plus or minus d1 square plus 8 into v1 square into d1 square divided by g into d1, and we can make it whole divided by 2. So here it will becomes 4 and divided by 2, and I can write it this one d2 is equal to, next d2 is equal to, final equation will get d2 is equal to d1 by 2 root of d1 square by 4 plus 21 v1 square d1 divided by g. That is final equation we will get from the there. So d2 minus d2 here small step is there, mathematical step is there, we can see in your in easy way, and d2 minus d1 is equal to depth of hydraulic jump. D2 minus D1 is depth of hydraulic jump. So here what I am going to tell you means this again I will explain you. This is d2 is equal to this one, d2 is equal to minus b1 quadratic equation plus b square minus 4ac divided to a, and d2 is equal to minus d1 plus or minus root of d1 square by 4 into a is equal to 1, and c for a is equal to 8, and this one c is equal to 1, and 2 into a is equal to 2 into 1. So next equation is next equation is it means d2 minus d1 root of d1 square by 8q square gd1. It means v is equal to, we are having the formula q into d. We are having the formula q into d. That means it means what will happen, 2q square gd1. It means 4 into 2 8q square by gd1 becomes. So that is the final equation for the hydraulic jumps. So if you are having any doubts, please ask question in comment box. Okay, thank you very much.